Hey everyone, quick news before the video starts. Kraylin's voice is currently out of commission due to an illness, so I will be covering for him in this video. Hello everyone, in the previous video I have designed an upside down, compact, portable, and super fast 3D printer called the Positron V3. It is a printer that boasts 180 by 185 by 180 millimeters of build volume, but it can be also folded down into just a filament spool box. In the previous video, I went through all the features of this printer as well as the print quality, which is excellent. I also explained the entirety of the design history from beginning to finish in the previous video. So if you want to see where the project came from, please check out the previous video. And thanks to all of you, it was a huge success. The design was recognized on multiple platforms. An active community was formed around this printer, and several manufacturers are interested in producing this design. If you are interested in getting updates and joining this community, please check out my Patreon and Discord server. The design file links are in the description. This is part 1 of 2 of the build series. In this video, I'll go over the mechanical component assembly as well as a little about the electrical system. In the next, we'll finish up the assembly process as well as go over some tips and tricks on the maintenance and operation of the printer. As a disclaimer, the Positron V3 is not currently a complete product. As of July 2022, Positron V3 is a functional prototype. As this project gets developed, things will likely change and deviate from this assembly guide. So please check out the updated assembly guides available at the time. Before starting the assembly process, it is necessary to get all the machine metal parts ready. Here are all the parts. Because I only have access to CNC machines, all the brackets are machined. But they can also be either laser cut or water jet. Whichever process you use, they have to be made according to the tolerances in the drawings to ensure the best result. The reason that these parts have a black or gray tone is that they have been anodized. Anodization makes the aluminum scratch resistant, and it also gives the piece a nice aesthetic. Anodization is actually fairly simple. After machining all my parts, they are cleaned in a bath of sodium hydroxide and electrolyzed in the solution of 30% sodium bisulfate by weight. Finally, the pieces are submerged in a hot dye bath, and the surfaces are stabilized by boiling the pieces in deionized water. There are many great tutorials for DIY anodization on YouTube. I will include one down in the description. However, this step is optional. Now I will go over some special features on some parts that are easy to miss. For the 90-degree bed holder, the 2 holes on the top are meant for press fitting in a 4x10mm dowel pin. This should be a nice permanent attachment, and the dolphin should fit nicely in the bed holder arms with very little wiggle room. For the Z-axis holder block, the channel should fit snugly into the MGW9 linear rail. And speaking of the MGW9 linear rail, one side should be drilled out to be 6mm in order to pass through a thumb screw. This rail is made out of hardened steel, so please use a drill tip with tungsten carbide. On the back of the faceplate, place 5 4mm rubber feet in this fashion. Another thing you need to prepare is the individual PCB boards, which brings me to the sponsor of this video, JLC PCB, from which you can get 5 PCBs for just $2. I used JLC PCBs to prototype all the PCBs for the Positron series. With their online PCB design platforms, Easy EDA, it is fast and easy to create PCB prototypes. If you wish to order PCBs for Positron 3D, navigate to the GitHub page containing all the design files, go to PCB design files, and download the Gerber, Pick, and Place, and BOM file. Then navigate to the order button on JLC PCB's website, upload the Gerber files, and check these settings. In the SMT assembly tab, upload the BOM and Pick and Place file. Make sure that you uncheck all connectors as they are not needed. Then press the order button and the PCBs should arrive within a week or so. And this is what the PCBs look like. I did not order the PCB with SMT service because I had all the components on hand. But you should really order with SMT service, as manual soldering SMT parts is a huge pain. With that, let's begin the assembly process. First, get the base plate. Then secure the Z-axis holder block onto the base plate with 3 M4x10mm screw. The next step is to get all the parts for the Z-axis motor assembly. Get the 48 teeth GT2 pulley and slide the 5mm by 40mm shaft into it like this. Secure the pulley with set screw. Then slide the 20 teeth GT2 pulley onto the top of the 48 teeth pulley. Next, get the pulley holder bottom and press fit F115ZZ flange bearing into it. Next, prepare the NEMA 14 stepper motor. The wire length should be around 19 centimeters. Mount the pulley holder bottom onto the NEMA 14 motor in this orientation and loosely secure it in place with 2 and 3x6 screws. Slide on the GT2 pulley assembly and get the 130mm GT2 belt loop and 16 teeth GT2 pulley. Slide both of them onto the existing assembly like this. Next, get the pulley holder top. Secure the pulley holder top onto the pulley holder bottom with an M3x15 socket head cap screw. While pulling tight all the pulleys, secure the pulley holder top completely in place by using 2 M3x18mm buttons head screws. Next, loosen the 2 bottom screws off the motor body on a back and secure on the NEMA 14 mounting point onto the motor with M3x28mm screws. Check the smoothness of the drivetrain by spinning it and make sure that it spins freely. Attach the Z motor assembly onto the base plate with 2 M3x10 button head screws, with one of them requiring a nut. And now the Z motor assembly is complete. The next step is for the A and B motor assembly. The motors are NEMA 17 pancake motors with a height of 20mm. Both of their lead wire length should be around 16 centimeters, and the shaft are trimmed down to 10mm. Secure the M3 motor mounts onto the stepper motor with 2 M3 5x6 screws. And now get the 4 15mm aluminum spacers. With the spacers, attach the A and B motors onto the base plate like so, using 25mm M3 button head screws with nuts on the end. And this is what it should look like with both motors mounted. Now let's get the Z-axis assembly. The first step is to make sure that the MGW9 rail for the Z-axis has proper preload. To put it simply, the block should slide with some proper amount of resistance on the rail. If your rail does not have the proper preload, I recommend replacing one side of the inner recirculating ball bearings with a slightly larger size, and reinsert the slider block onto the rail. To mount the Z-axis rail onto the 1030 aluminum extrusion, insert 5 M3x8 socket head screws onto the rails, and loosely screw M5 T-nuts. Slide the assembly onto the rail and make sure that the rail is centered across the entire length of the extrusion. Then firmly secure in the rail. Get the Z-axis top stopper and secure that in place with an M3x12 socket head screw and a nut. Screw on the 90-degree pad holder with 2 M3x8 button head screws. The next step is to get the 6-pin magnetic connector and solder 4 wires onto the connector according to this diagram, and attach a 1/4-inch cable sleeve to the outside of the wires. The total length of the wires should be around 56 centimeters. For the next, insert the 4 wires through the slot on the belt and connector holder and press fit the connector in place. And make sure that it is oriented in this manner. Feed the wires through the indent on the belt and connector holder, and hot glue them in place to make sure it does not move. Finally, screw on the belt and connector holder onto the axis slider with two M3x12 flathead screws. The next step is to get all the aluminum brackets for the Z-axis. The brackets are for mounting the GT2 idlers for the Z-axis, as well as to stabilize the motion of the Z-axis during the folding process. The first GT2 idler mounts onto the Z-axis belt tensioner lever. Locate the countersunk side of the bracket, insert an M3x18 flathead screw into it, add a washer and put on the GT2 idler onto it. Finally, use an M3 nylon log nut to secure the idler in place. Repeat the same on the Z-axis bottom holder left, but instead of a washer, use a normal M3 nut to stabilize the screw in place. And employ the same method of using nylon lock nuts to secure the idler bearings in place. Do not over tighten the nuts, as that can cause the idler bearings to seize up. Repeat the same action for the idler top holder. To mount the bracket onto the rails, insert the M4x10 screws into the 4mm holes, and loosely add on an M4 nut onto the other side. The exception is for the belt tensioner lever, where an M4 nut with a 3.1mm spacer is added, and M4 washers is added on the other side. After these actions are finished, slide on the idler top holder first, and the belt tensioner lever second, and the Z-axis bottom holder left third, and secure them in whilst making sure that they are parallel with the extrusion. The belt tensioner lever should form an 80-degree angle with the extrusion. This way the belt can get into an overlock position when deployed. The next step is to gather all the components for the extruder. First, put on the extruder base and press in the mini 5mm bearing. Next, get the 50 teeth BMG drive gear and secure on the dual gear extruder drive gear onto it just like this. And secure the drive gear assembly to the bearing that we just pressed in. Then lower the extruder mid-body over the existing assembly and screw on an M3x12 flathead screw. Next, get the extruder slider on. In my case, it already has a dual gear extruder idler gear already pressed in like this, and slot this into the assembly like so. Then, get the extruder cap and press in a mini 5mm bearing, and secure the extruder cap onto the existing assembly with two M3x6 button head screws. Use an M3x32 socket head screw with a nut through the entire assembly to clamp it in place. Next, I found a random spring from an RC car suspension, and I cut it off a 15mm section. Press fit the spring onto the extruder. Next, add an aluminum bracket for the extruder and screw on the bracket to the extruder body with two M3 5x5 flathead screws. And insert two M4x8 screws onto the bracket and loosely screw on two nuts. Slide the extruder assembly onto the other side of the Z-axis rail. Push a 72mm long PTFE tube until it fits into the extruder body. And finally secure the extruder in place. Then slide on the Z-axis holder right and secure it in place. Then place the Z-axis assembly onto the Z-axis holder block to make sure that it fits correctly. The next step is to attach the control boards, but before doing so, flash the firmware onto the SKR Pico and install Clipper on Raspberry Pi. First, get Raspberry Pi. Both Raspberry Pi 3, 4, and 0 works also. Then you need to install Clipper interface onto the Pi. In my case, I used a pre-existing Raspberry Pi image called Fluid Pi, and follow the Fluid Pi installation guide, link in the description. The most important parameter to select is the MCU as RP2040 and UART communication on GPIO 0 and 1. Use the make command to make the UF2 file. Then download the file onto your computer. Next, follow the BTT tutorial on how to flash the SKR Pico and flash the SKR Pico with the UF2 file. The next step is preparing the PCB. Use a saw to carefully separate the PCB into its individual pieces and sand the edges smoothly. For the bed edge heaters, carefully saw through the middle of the slots and sand to make sure the copper traces are smooth. From the pieces, select the L-shaped PCB adapter that looks like this. Solder 2 rows of female DuPont connectors onto the back of it, with each row consisting of 15 connection points. Snap the PCB adapter onto the Raspberry Pi to make sure it fits like this. Then get an IDC 10-pin connector, cut off a 19cm section, and fan out all the wires. Locate the 10 rows of holes. The first hole should be labeled red. Solder the cable wires in order from the first red wire and down the line. After soldering, this is what the wire should look like. The next step is to attach the PCB bracket for the screen. Remove the connectors from the back of the screen and attach the PCB onto the screen like so, and solder the pins to the PCB. On the other side, push a female IDC 10 connector and pay attention to the orientation of the connector. After seating in the connector, solder it in place. Next, get 4-pin Molex connector with 18 centimeters of wire and solder them according to this diagram. Now you are ready to test the software to make sure everything is working. Connect the Raspberry Pi, the SKR Pico, and the screen together. And power on the system with a USB-C connector on the SKR Pico. Make sure the power jumper is selected to USB on the control board. After powering up the system, connect to the Pi via SSH and install Good TFT from GitHub and Auto Hotspot. Good TFT is the 3.5-inch TFT driver, and Auto Hotspot is the program that turns the Pi into its own local router with its own Wi-Fi whenever it is not connected to your home Wi-Fi. This way you can access the printer as long as you are within 20 meters of it. Both tutorials are linked down in the description. Finally, copy and paste the printer CFG into the configuration files in Clipper. If you face any difficulties during this step, I included an excellent tutorial by Nero3DP down in the description, in which he goes in depth into the installation of Clipper onto Raspberry Pi and SKR Pico. After restarting, you should see that the screen is working and displays the printer status. If you get to this step, congratulations, all 3 boards are connected correctly. Use hot glue to secure the wires to make sure they don't wiggle loose. The next step is to assemble the heater block. For this step, gather all the necessary components for the hot end. First, insert the brass insert into the heater block, and push in the heater cartridge perpendicularly into the heater block. Next, screw in the nozzle until it is finger tight, and repeat the same for the heat break. Finally, attach the thermistor in the same way that Ender 3 hot ends attach it. And this is what the final result should look like. To make sure that nothing leaks, push the heater cartridge wire into a 20-volt power supply for 1 minute. This will make the entire heater block very hot. Then go in and hot tighten both the nozzle and the heat break. Get the heatsink and the 1/4-inch MPT PTFE coupler and a 38cm length of Capricorn PTFE tubing. Push the heatsink onto the existing heater block assembly and secure it in place with a set screw, and start to thread in the PTFE coupler until it is about halfway in place. Then push in the PTFE tube until it bottoms out, then screw in the PTFE coupler all the way. This method makes sure that the PTFE tube will sit flush with the brass insert to prevent any leaks. And this is what the assembled hot end looks like. Now we can begin assembling the rest of the tool head. First, get the 3010 24-volt blower fan and one of the 25, 10, 24 volt fans and connect them in parallel. The wire length should be around 58 centimeters and the end should be a Molex style connector. The other 2510 fan is also wired onto a Molex connector with a length of 58 centimeters. The next step is to get the 3D printed Toolhead interconnect and heat press in a brass insert. Attach the hot end cooling fan to the aft of the Toolhead interconnect and make sure the wire is facing downwards. Attach the other two fans onto the other two mounting locations on the interconnect. Use 4 M3x12 button head screws to mount the fans onto interconnect. Then screw on the IR bed probe with 2 M3x5 button head screws. Before fully screwing on the probe, route the wires from the fans underneath the probe and secure the IR probe in place. Next, get the top cover and screw it onto the existing assembly with 2 M2 5x8 flathead screws. Then secure on the hot end assembly with 2 M3x23 flathead screws. Screw on 2 M3 9-lock nuts onto the end of the screws to prevent the hot end from coming loose. After securing the hot end assembly, plug in the bed probe wires and Toolhead assembly is complete for now. Now it is time to mount the boards onto the base plate and connect everything electrically. First, slide on the Z-axis and secure it in place with an M6x14 thumb screw. Then plug in the 4 motor wires according to this diagram and screw in the control board into the base plate with 4 each of M2.5x12 button head screws, M2.5 nuts, and M3x3mm spacers. Get the bed heater and temperature wires and attach them onto the side of the extruder with some zip ties. Get the Toolhead assembly and push the PTFE tube into the extruder. On the other side, use zip ties to bundle the wires and push on 1/4-inch cable sleeve to bundle the wires and PTFE tube. Use zip ties to hold the wires in the proper location. When the cable sleeve reaches the extruder, incorporate the extruder motor wire and the heated bed wires into the cable sleeve and route following the curve on the extruder body. Use a zip tie to secure the cable bundle onto the extruder. Before connecting all the wires, let's make the RGB LED lights for the printer. Locate 2 pieces of PCB like this. They should already have components on them, but in my case I had to solder them by hand. Then solder 3 pairs of wires between the boards to connect them like this. Get the LED indicator holder and press in the laser cut clear acrylic onto it. And hot glue the square LED PCB onto the other side. Hot glue the other LED PCB onto the EXP connector holder. Now everything is ready, connect all the wires to the boards according to this wiring diagram. Do not connect the power cables yet. And that is all for part 1 of the assembly video. I hope you enjoyed the process, and in the next video we are going to assemble the rails, the case, and the build plate. If you like what I do, please consider subscribing to my channel and support me on Patreon. If you have any questions, I recommend you go join my Discord where you can get help from me and the community. Thank you very much for watching and see you soon.